Come fast, come fast. All of you got the new link, right? You can enter into that link. Okay. Sorry, there was a network issue, and above that, in a urgency, I clicked on end stream. So we came into new link due to that reason. Okay? I should have clicked resume. Instead of that, I clicked on end stream. Okay, now? Sorry for that. Fine. So all of you are okay. All of you are here. Shall I start? Shall I continue? Okay. Fine. So all of you note down this relation. All of you note down this relation between. All of you note down this relation between number of atoms in a crystal structure. In that case, what will be the octahedral wards and what will be tetrahedral wards? Note down this relation. Okay? So total number of atoms, if it is n, you can take x, you can take y, it's up to you. So total number of atoms, if it is n, then the number of octahedral wards will be equal to n. But number of tetrahedral wards will be equal to 2n. That is because difference in their size. So that's what we can see the relation between the number of atoms and the number of wards in a crystal structure. All of you have understood? Okay? Any doubts? Any doubts? Okay, now when I am talking about first row and second row, when I am talking about first row and second row, that's what I explained when I was talking about octahedral wards and tetrahedral wards. Right? That's what I was talking about, octahedral wards and tetrahedral wards. So like this, if I go with next row, that is third row. So when I am talking about second row, that's what I have explained what you mean by tetrahedral wards and what you mean by octahedral wards. Same way, if I talk about third row, placing the element in the third row. So in that case, what will happen here is we can have different types of packing. So that will be, one will be called as hexagonal close packing. One is called as hexagonal close packing. Short form can be HCP. Hexagonal close packing. Short form is HCP. Okay? And now, same way we have another one which is called as cubic close packing. Another one will be cubic close packing, which is also called as CCP. Which is also called as CCP. So what I mean to tell you is, we have some of the metals which can go with hexagonal close packing, and we have some of the metals which can go with the cubic close packing. Okay? Efficiency wise they are same, which we will come to know later. So what I mean to tell you is, when I am talking about first and second row, we have observed there will be formation of octahedral and tetrahedral wards. When I am placing the third row, I can place in different pattern. I can place in the sense nature. It is present in different pattern. Elements are arranged in the different pattern. So based on that, what you can remember here is, we can have either hexagonal close packing, cubic close packing, and even we can have the simple cubic close packing, simple cubic close packing, and another one is body centered close packing. Another one will be body centered close packing, SCP, and another one is body centered close packing. So we can have majorly 4 types. Body centered close packing, BCP. So HCP, CCP, SCP, BCP. Okay. So that's where we have the different terms. That's where we have the different terms. Okay. So now body centered close packing, simple cubic close packing, cubic close packing, and hexagonal close packing. Okay. So that's where we have the different types. Okay. Even some people they will tell BCC packing also they will tell. They will call it as SCC packing, CC packing, and HC packing. Anything is fine. Even they will call it as BCC also. Okay, that's where we have the different types of packing. Okay, now you should remember efficiency wise, which is more efficient, we have to calculate. That's where we have the important one. But before going for that calculation, we will solve some of the problems which you can expect for your board exam. Okay. So one thing which is related to that particular equation, that is 1n, 2n, n and all I told now. So octahedral watts and all. So related to that, we have to solve some of the problems. All of you can take it down. So write it down. A compound is formed. A compound is formed. A compound is formed by 2 elements. A compound is formed by 2 elements A and B. A compound is formed by 2 elements A and B. Atoms of the element A, atoms of the element A, atoms of the element A will make HCP. Atoms of the element A will make HCP, and atoms of element A will make HCP, that is hexagonal close packing, and element B will occupy tetrahedral watts. Element B will occupy tetrahedral watts. Element B will occupy tetrahedral watts. What is the formula of the given compound? So what you can do is, today while at home you can go through example 1.1 and example 1.2 in your textbook, page number 16. You can go through that, but now we will solve related problems. Okay? So we have 2 elements. What is that given data? So given data is, so we have 2 elements A and B in forming that particular crystal structure. It can be an ionic compound, no doubt. Okay? Where A will be forming HCP. A will be forming HCP, hexagonal close packing, and B will occupy the, which one I told, octahedral or tetrahedral? It will occupy the tetrahedral. Watts. Okay. Now they are asking what is the formula for the given condition or given compound. What is the formula of the given compound? Now we have to apply whatever relation I have given. Okay. Consider A, since it is making hexagonal close packing, that we are talking about total number of atoms in a crystal structure. So that will be, A will be equal to N. A will be equal to n, total number of atoms. Right? Now since B is occupying tetrahedral wards, naturally it should become 2n. It should become 2n since it is a tetrahedral wards. So now therefore formula should be, formula of the compound will be, what will be that? So in our base it will be 1:2. Relation between A and B will be 1:2 ratio, because one is n and another one will be 2n. So therefore formula of the compound will be AB2. Formula of the compound will be AB2. If by chance if they would have given B will occupy the octahedral wards, then the formula of the compound would have been AB. Formula of the compound would have been AB if they would have given octahedral wards. Since they have given tetrahedral wards, it will be AB2. Any doubts? All of you have understood? So this type of problem for 2 marks you can expect in your board exam also, and for competitive exams they will ask. Okay? Shall we move to the next one? Okay? So it is from your in-text questions. Write it down. A compound forms hexagonal close packed structure. A compound forms hexagonal close packed structure, that is HCP. What is the total number of wards? What is the total number of wards in 0.5 mole of it? What is the total number of wards in 0.5 mole of it? And how many of these are tetrahedral wards? Once again I will repeat. A compound forms hexagonal close packed structure. What is the total number of wards in 0.5 mole of it? And it is a continuation now. How many of these are tetrahedral wards? How many of these are tetrahedral wards? Can anyone solve? And you have to calculate how many of these are tetrahedral wards. Okay, so what is that given data? Given data is 0.5 mole, right? They are talking about 0.5 mole of a given compound, right? They are not given anything. So it is understood that when I am talking about 0.5 mole, it should be half of the Avogadro's number. Because 1 mole is Avogadro's number, it should be half of the Avogadro's number, that is 3.011 into 10 to the power of 23 number of atoms. So we are dealing with the 3.011 into 10 to the power of 23 number of atoms, which we have assumed it as n. Forget about CCP, SCP, whatever it might be. We will go with the number of atoms, right? So 0.5 mole means I have to have 3.011 into 10 to the power of 23 number of atoms, that will be capital N. Now what will be the tetrahedral wards? Therefore tetrahedral wards, first we will solve for tetrahedral wards. So total number of tetrahedral wards will be 2n, that is nothing but Avogadro's number, 3.011 multiplied by 2, that is 6.022 into 10 to the power of 23. So that will be total number of tetrahedral wards. That will be total number of tetrahedral watts. So that's what I am going to get by multiplying the total number of atoms by 2. Because what is the relation? Total number of atoms if it is n. Now total number of tetrahedral watts will be 2n. So that's what I have done. So I will get back the Avogadro's number. Now what will be total number of watts? Therefore, total number of watts, that means it will be including octahedral and tetrahedral watts, right? So which is including octahedral plus tetrahedral watts. And all of us we know octahedral watts will be same. That is 3.011 into 10 to the power of 23 plus. And here also we have 6.02 into 10 to the power of 23. That will be 9.033 into 10 to the power of 23. That will be total number of watts. All of you have understood? So this is how this problem can be solved. So this is one answer and this is another answer. So total number of tetrahedral watts will be Avogadro's number, since they have taken 0.5 mole of the original compound. Then total number of watts will be 9.033 into 10 to the power of 23. Fine? All of you have understood? Any doubts until now? You can expect these type of problems in your competitive exam also, please remember. But any doubts here? In that case, we will solve another one, and there will be one homework for you. One is you have to go through the examples, whatever they have given, and you have to solve in text questions. You have to solve in text questions, whatever we have done concept based on that. Okay, in text question is, that is 1.14 and 1.16. We have to solve 1.14 and 1.16. Okay, so take down another problem, similar type of problem. Atoms of element B, atoms of element B forms HCP structure. Atoms of element B forms HCP structure. And atoms of A occupies the 2/3 of the tetrahedral watts. 2/3 of the tetrahedral watts. What is the formula of the given compound? 2/3 of the tetrahedral watts. What is the formula of the given compound? Fast. I will give a hint. Now, what is that given data? What is that given data? They have told A will form HCP, right? And B will be 2/3 of tetrahedral watts. 2/3 of tetrahedral watts. If I assume this one as capital N, total number, now it will be 2 into 2/3. of capital N. Right? 2 into 2/3 of the capital N. Now you can identify what should be the answer. Why 2 into? That is because tetrahedral words will be 2n. Tetrahedral words will be 2n. So therefore 2/3 of the tetrahedral words. So the answer should be A4B3. So the answer should be A4B3, right? So because the ratio, you have to identify the ratio of this. So that's where we have the ratio. So this will be n and this will be 2 into 2/3 of the n. So therefore it will be A4B3. B occupies HCP structure. What I have given? B occupies HCP structure, I told. Oh, then it should be ulta, na? Okay, fine. It should be reverse. Okay, formula should be reverse. A4B. Then here it should be here it should become B4A3, na?
So B occupies HCP.
No, but I have written, I have given like that.
Huh.
Okay, then here on the have to change. B occupies and A. Okay, then it will be same. Okay, then final answer will be same. While writing, I have written ulta. Right? So final answer will be same. Okay? So that's where we have the problem. Any doubts? So you can solve those in text questions, whatever is there, which I have mentioned. Okay, na? Any doubts? So on this you can expect the question. This type of problems you can expect in your board exam also, and competitive exam definitely. You can expect the question. If it is for board exam, it will be asked for 2 marks. Not for 1 or not more than 2. It's for 2 marks question. Okay? Any doubts? Anyway, I will stop here. So tomorrow we are going to start with the packing efficiency, which is once again very important one with respect to your exam point of view. Okay? Thank you. Thank you very much.